Hello everyone, welcome to Mahila Samaja digital classes. This is children. Here let us group the 2 fractions side. See here minus 2 by 3 into 3 by 5 and let us group the minus 3 by 5 into 1 by 6. See children, this 3, the numerator in the 3 and the denominator in the 3 get cancels, and in this part 3 ones are 3, 3 twos are 6 get cancels. So that now in the next step write down the remaining things. Children, here the symbol is minus, minus into plus. Children, minus into plus is minus itself. Then 2 ones are here, 3 and 3 get cancelled, so that 2 ones are 2 by 5 ones are 5 plus write down the 5 by 2 as it is. Then here 3 ones are 3, 3 twos are 6 get cancelled, so that let us multiply the numerator and denominator. Children, 1 ones are 1, then 5 twos are, it is 10. 5 twos are 10. So now in the second step we got the simplified fraction of the first step, simplified form of the first step. Observe the second step here, minus 2 by 5 plus 5 by 2 minus 1 by 10 is there. See here among these three fractions 2 negative signs are there and 1 positive sign is there. Children, so here whether we want to add the terms or we want to subtract the term. Before going to add or subtract the fractions, let us equalize the denominator. If denominators are not equal means we cannot add the numerators directly. So that children, observe the denominators here. In the first fraction the denominator is 5. In the second fraction the denominator is 2. In the third fraction the denominator is 10. You can observe here. See here there are 3 different denominators. To equalize these denominators we want to find the LCM for these denominators. So let us take 5, 10, 2 here in the separate column, working column. First see 5 and 10, 5 and 10 are divisible by 5. So that let us take the 5 here. 5 ones are 5, 5 twos are 10, then the 2 does not divisible by 5, so that write down the 2 as it is. Children, now here in the second step we got the terms as 1, 2, 2. Here 2, 2 is there, it is commonly divisible by 2, so that take the 2 here, write down the 1 as it is. 2 ones are 2, 2 ones are 2. So we got all the reminders, that means all the quotients as 1. Now let us find the LCM by multiplying the terms 5 and 2. Children, 5 twos are 10. So this is the way of calculating the LCM for the 3 different terms. Children, you studied this step in your previous class itself. So we got the LCM as 10. We got the LCM as 10. So we want to take this 10 as the common denominator for all these 3 fractions. Children, here denominator is 5, here the denominator is 2, here the denominator is 10. So that let us take the denominator as common denominator as 10 here. Children, see here in first fraction the denominator is 5. We raise it the 5 into 10. That means 5 twos are 10. So that multiply the numerator also with 2. 2 twos are 4. So did you understood how we obtained the 4 here? Children, here the denominator is 5. We raised the denominator to 10. 5 twos are 10. That means 2 times we multiplied the 5 to make it as 10. So that multiply the numerator also with the 2. 2 twos are 4. Then write down the plus symbol as it is. Then see here children, in the second fraction the denominator is 2. We converted the 2 into 10. That means 2 5s are 10. We raise it the 2 to 10. 2 5s are 10. So that 5 5s are 25. 5 5s are 25. So to make the 2 as 10, we multiplied with the 5. So by the rule of fractions, let us multiply the numerator also with the same number. So 5 5s are 25. Then here in third fraction the denominator is 10. Here also the denominator is, that denominator what we take, that is also 10. So that there is no change in the denominator, so that there is no change in the numerator also. If there is no change in the denominator, then there is no change in the numerator also. So that let us write the 1 as the numerator as it is. Write down the minus symbol as it is and write down the 1. Children, here you observe we got the final form as minus 4 plus 25 minus 1 by 10. Now let us group the negative terms. See, minus 4 minus 1 is there. Two negative terms. If in front of any two numbers there are minus signs, means we want to add those two numbers. That means we want, if two negative numbers are there, means we want to add the numbers. So that, see, these are the numbers with the same signs. Let us add 4 and 1. 4 plus 1 is 5. The greater term sign is minus. So the answer is minus 5, then plus 25 by 10. Children, again the final form of the third step is minus 5 plus 25 by 10. Children, here observe the minus 5 and plus 5. Here in front of 5 minus is there, in front of 25 plus symbol is there. There is opposite symbols in front of the numbers. So that if opposite signs are there, means we want to subtract the two numbers. So here 25 is the greater number. Let us subtract the 5 from 25. 25 minus 5 means we will obtain the difference as 20. Then the greater term has positive sign, so that here also there is the positive sign. If no sign means it indicates that there is a positive sign. By the denominator remains as it is, write down the denominator as 10. Now 20 by 10 is the simplest form of the above step. 20 by 10 means we can easily cancel out the 20 by 10. 10 ones are 10 twos are. So the final answer is 2. The final answer is 2. Children, I think you understood this problem. Now let us move on to the next problem. Children, this is your second problem. This is your second problem. 2 by 5 into minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. Children, here see, come to the solution. 2 by 5 into minus 3 by, that means write down the problem as it is in the first step. 2 by 5 into minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. Children, make the two fractions into a group. That means first two fractions as one group and the next two fractions as second group and the last two fractions as the third group. Children, here see, observe these two fractions. 2 by 5 into minus 3 by 7. Here no common factors in the numerator and denominators. So that directly multiply these two fractions and write down the product here. Children, see the symbol plus into minus is equal to minus. Then 2 3s are 6. 2 3s are 6. Numerator is 6 itself. Then multiply the denominator. 5 7s are 35. 5 7s are 35. So that the simplified form of these two is minus 6 by 35. Then children, in second group, write down the minus as it is. In second group, 3 1s are 3 get cancels and 3 2s are 6. Here 3 is the common factor is there in the numerator of second fraction and the denominator of first fraction. So that 3 1s are 3, 3 2s are 6 get cancels. Now write down the remaining things by multiplying them. 1 ones are 1. 1 ones are 1. Then 2 twos are 4. 2 twos are 4. Then write down the plus symbol as it is. Here also common term is there. 2 ones are 2. 2 ones are 2. 2 sevens are 14. So that the remaining things are 1 ones are 1. 1 ones are 1 and 7 fives are 35. 7 fives are 35. Children, observe the simplified form of the first step. See, minus 6 by 35 minus 1 by 4 minus 1 by 4 plus 1 by 35. Children, here let us group the denominators fractions with the equal denominators. That means minus 6 by 35 plus 1 by 35. Then write down minus 1 by 4 as it is. Group these two numbers here and write down the remaining thing as it is here, minus 1 by 4 here. Now children, see here, if the denominators are equal means we can add or subtract the numerators directly. So that here for both the terms the denominator is 35. So that write down the denominator as 35. Then write down the numerator minus 6 plus 1 as it is. Then write down the minus 1 by 4 here as it is. Now see children, here in front of 6 minus sign is there, in front of 1 plus symbol is there. That means minus and plus symbols. If opposite symbols are there means we need to subtract those two terms. 6 minus 1 means we'll get the difference as 5. 6 minus 5, 6 minus 1 means 5. See here the 6 is the greater term, it has the minus sign, so that minus 5 is the final form of minus 6 plus 1 by 35 minus 1 by 4. Write down the minus 1 by 4 as it is. Children, observe here, this is the simplified form of the above step, minus 5 by 35 minus 1 by 4. Here the denominators are different. Here the denominator is 35 and here the denominator is 4. Denominator is 4. So that we cannot perform the numerator operations directly. So that let us find the LCM for these two terms. Children, multiply the 34, 35 and 4 and we can write it as common denominator, because 35 and 4 has no common factor. 35 and 4 has no common factor, so that we can write the product of 35 and 4 as the LCM of those two numbers. And we can also find the LCM which I explained in the previous method. Children, here see 35 comma 4. 35 ones are 35, write down the 4 as it is. Again write down the 1 as it is, 4 ones are 4. If we multiply 35 and 4, we'll get the LCM as 140. So instead of these two terms, let us take the LCM as 140. To equalize the denominators, we retain the LCM as 140. So now here to make the 35 into 140, we want to multiply the 35 with 4 times. So that let us multiply the 5 also with 4. That means numerator also 4 times. Minus remains as it is. 5 4s are 20. Minus 4 35s are 140. So that 135s are 35. Children, here this is the simplified form of the above step. Minus 20 minus 35 by 140 is the simplified form of the above step. Here see children, minus 20 and minus 35 both have negative signs. That means those are negative rational numbers or negative integers we can say. So let us add, if minus sign is there means we want to add. Let us add those two numbers. 20 plus 35, the answer is 55. Here the greater number is 35. 35 carries minus sign. So that here in the sum of those two terms we want to write the minus sign. So minus 55 by 140 is the simplified form of the above step. Now see, these two terms, numerator and denominator, has the 5 as common factor. So divide these two terms by the 5. 5 11s are 55. 5 2s are 10, 5 8s are 40. So that the answer obtained is minus 11 by 28. Minus 11 by 28. I hope you understood the problem, children. See, while explaining itself, in your notes, you have to copy down the problems. Now, let us move on to the second main. Write the additive inverse of each of the following. See, they had given 5 rational numbers. For those rational numbers, we want to find we want to write the additive inverse. Children, for 2 by 8, for plus 2 by 8, minus 2 by 8 is the additive inverse. Then for 5 minus 5 by 9 plus 5 by 9 is the additive inverse. Children, here the third one is minus 6 by minus 5. Here the minus sign and the minus sign get cancels. The simplified form of minus 6 by minus 5 is 6 by 5. So the additive inverse of 6 by 5 is minus 6 by 5. The additive inverse of, here no sign is, plus sign is there. So the additive inverse of plus 6 by 5 is minus 6 by 5. Then for 2 by minus 9, the additive inverse is 2 by plus 9. Or minus 2 by 9, the additive inverse is plus 2 by 9. In the last case, for 19 by minus 6, the plus 19 by 6 is the additive inverse. I hope you understood, children. Let us move on to the next main. Children, the third main is verify that minus of minus x is equal to x. Minus of minus x is x. For they had given the x values. We want to verify the statement minus of minus x equals to x. So, in the first problem, they had given the x value as 11 by 15. First, let us take the LHS. LHS is minus of minus x. Children, write down the minus sign as it is. Then put the common bracket as it is. Write down the minus sign of the statement as it is. Instead of x, write down the x value here 11 by 15. We know the x value as 11 by 15. That means they had given the x value as 11 by 15. So that write down the x value as 11 by 15. Now let us multiply. Here common bracket is there, means bracket is nothing but into symbol. So that multiply the minus and minus sign. Minus into minus will get the plus. Now then 11 by 5. So plus 11 by 5 means we can write it as plus 11 by 15. So plus 11 by 15 means we can write it as 11 by 15 itself. So x value is 11 by 15. X 11 by 15 is equal to x. So that x is nothing but RHS of the statement. Here LHS equals to RHS. Hence verified. Then in the second x value, they had given the second value. That means they had given the x value in the second problem as minus 13 by 17. So LHS is minus of minus x. Write down the minus as it is. Take your flower bracket. Minus of minus 13 by 17. Close the flower bracket. Children, here see. First write down the minus sign as it is. Then flower bracket also as it is. Now multiply the minus into minus. We'll obtain the plus sign. Then write down the 13 by 17 as it is. Now children, we got the simplified form of the above step as minus into plus 13 by 17. Now multiply the minus into plus. Minus into plus is minus. Minus into plus is minus. Write down the 13 by 17 as it is. Children, observe the given problem. X value is minus 13 by 17. So minus 13 by 17 is equal to x. Here x is nothing but RHS. So LHS is equal to LHS of the statement is equal to RHS of the statement. Hence the statement is verified. Children, the statement is minus of minus x is equal to x. I hope you understood this one. Now let us move on to the next main. Children, this is the fourth main of your 2.1 exercise. So in the fourth main, we want to find the multiplicative inverse for the following. Children, here they are given some rational numbers. For them, we want to write the multiplicative inverse. For every rational number, its reciprocal is considered as multiplicative inverse. Children, there is no change in the sign. Note that while writing the multiplicative inverse, there is no change in the sign. While writing the additive inverse, only there is the change in the sign. Children, minus 13 means the multiplicative inverse for minus 13 is minus 1 by 13. Then second one, minus 13 by 19. There is no change in the symbol. Write down the minus as it is. 13 by 19 means we want to write it as 19 by 13. Then 1 by 5 means 5 by 1. 5 by 1 is nothing but 5. For 1 by 5, 5 is the multiplicative inverse. Children, for minus 13 by 19, minus 19 by 13 is the multiplicative inverse. In the fourth one, observe the fourth one. See, minus 5 by 8 into minus 3 by 7 is there. So, let us simplify these rational numbers. See, multiply the minus and minus, will obtain the plus sign. Minus into minus equals to plus. Then 5 3s are 15. Then 8 7s are 56. So that the simplified form of minus 5 by 8 into minus 3 by 7 is plus 15 by 56. So the multiplicative inverse of plus 15 by 56 is 56 by 15. Plus symbol remains as it is, 56 by 15. Here only the change in the numerator and denominator. Then in the next one, minus 1 into minus 2 by 5 is equal to, see here, let us simplify these rational numbers also. Minus into minus plus. Then 1 into 2 by 5 means 2 by 5 itself. So the simplified form of the given problem is plus 2 by 5. So plus 2 by 5. For this, the multiplicative inverse is 5 by 2. Then for minus 1, the multiplicative inverse is minus 1 itself. I hope you understood, children. Now let us move on to the next main. Children, here in the fifth main, we want to name the property. Just we want to name. We want to write the name of the property under multiplication used in each of the following cases. See, in first one, minus 4 by 5 into 1 is equal to 1 into minus 4 by 5 equals to minus 4 by 5. That means if we multiplied any number with 1, we'll obtain the same number itself. So that here we multiplied the numbers with 1. So it is considered as identity element of multiplication. The property used here is identity element of multiplication. Then in the second one, minus 13 by 17 into minus 2 by 7 equals to minus 2 by 7 into minus 13 by 17. In these two, see here, a into b equals to b into a. Here, multiply the rational numbers by changing their orders. So that the property used is commutative property. Then, see children here, minus 19 by 29 into 29 by minus 19 means numerator and denominator cancels. Will obtain the product as 1. So that the property used here is multiplicative inverse property. Children, now let us move on to the sixth main. See, multiply 6 by 13 by the reciprocal of minus 7 by 16. Children, first write down the reciprocal of minus 7 by 16. The reciprocal of minus 7 by 16 is minus 16 by 7. So write down the 6 by 13 as it is into minus 16 by 7. Children, multiply the symbols, plus into minus, minus. 6 16s are 96. Then 13 sevens are 91. So that the final form of the product of 6 by 13 and reciprocal of minus 7 by 16 is minus 96 by 91. I hope you understood, children. Now let us move on to the next main. Children, in the seventh main, tell what property allows you to compute the given expression. Compute means calculate. What property? Just we want to name the property, that's it. Here, see children, 1 by 3 into 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. See children, here I forgot to group the digits here. 6 and 4 by 3 are grouped in first case. In second case, 1 by 3 into 6 are grouped. So here we are multiplying the fractions, or we are multiplying the rational numbers by grouping differently. So that the property used here is associative property for multiplication. Then the 8th main, children, is 8 by 9. Is 8 by 9 the multiplicative inverse of minus 1 by 8? Why or why not? If it is yes, we want to say why. If it is no, we want to say why not. That means we want to give reason for our answer. Children, actually for 8 by 9, minus 1 by 8 is not the multiplicative inverse. By seeing itself, we can say because, see children, as I said, while writing the multiplicative inverse, only there is the change in the numerator and denominator. There is no change in the symbols. Say in the problem, that means in 8 by 9 positive sign is there, but in minus 1 by 8 there is negative sign. That means here the signs are changed. So that we can say directly as 8 by 9 is not the multiplicative inverse for minus 1 by 8. But we want to give the reason for that. So that let us write the 8 by 9 into minus 1 by 8. Children, it is in mixed fraction. It is in mixed fraction. Let us convert this mixed fraction into improper fraction. See, write down the 8 by 9 as it is. 8 ones are 8 plus 1. 8 ones are 8 plus 1 means we'll get the 9 by 8. Then symbol remains as it is, minus 9 by 8. Children, here then 8 and 8 get cancels and 9 and 9 get cancels. The product obtained is minus 1. So that the product is not equal to plus 1. So that minus 1 by 8 is not the multiplicative inverse for 8 by 9. Children, I hope you understood this one also. Now let us move on to the next main. Children, here the ninth one is 0.3, the multiplicative inverse of 1 by 3. Why or why not? It is the similar problem to that of 8th problem. Children, first let us simplify the 0.3 and 1 by 3. Children, we can write the 0.3 as 3 by 10. Then we can write the 1 by 3 as, children, 3 3s are 9, 9 plus 1, 10. So we can write it as 10 by 3. Therefore, 0.3 into 1 by 3 equals to 0.3, the simplified form of 0.3 is 3 by 10, and the simplified form of 1 by 3 is 10 by 3. So let us cancel out the 10 and 10. Then 3 and 3. So that the product obtained is 1. Therefore, 0.3 is the multiplicative inverse of 3 1 by 3. We multiplied these two, we obtained the product as 1. So that that means 0.3 is the multiplicative inverse of 3 1 by 3. I hope you understood, children. Now let us dive into the next main. Children, the 10th main, answer the following. We want to give the answer for the questions. The first one is, I think I modified the statement. I modified the heading. Maybe you can write this heading also, or what is there in your textbook, you can follow that heading also. Children, the first question is, the rational number that does not have a reciprocal is 0. The rational number that does not have a reciprocal is 0. Then the second one is, the rational numbers that are equal to their reciprocals are 1 and minus 1. Then the third one is, the rational number that is equal to its negative is 0. The rational number that is equal to its negative is 0 because 0 is neither positive nor negative. So that the one and only rational number which is equal to its negative is 0. Now children, let us move on to the next main. The next main is fill in the blanks. Children, the first fill in the blanks is 0 has dash reciprocal. That means 0 has no reciprocal. The numbers 1 and minus 1 are their own reciprocals. Then the reciprocal of minus 5 is minus 1 by 5. The fourth one is reciprocal of 1 by x, where x is not equal to 0 is x itself. Children, here is not equal to. Instead of that, symbol is there in your textbook. You can follow that one itself. Now, fifth one is, the product of two rational numbers is always a rational number. The reciprocal of a positive rational number is positive rational number itself, because as I said, if while writing the reciprocal, there is no change in the symbols, there is no change in the sign, so that the reciprocal of positive rational number is positive rational number itself. Children, I hope you understood all the problems of this exercise. To here, your exercise get completed. Children, this is the end of the exercise 2.1. Children, if you have any doubts, means you can post the doubt in the WhatsApp group. Thank you, children. Thank you, children. Thank you, one and all.